Okay, let's unpack this whole thing. Imagine you're building, say, an online store. Pretty common scenario, right?
Right.
You need to check stock, process a payment, maybe update loyalty points, arrange shipping.
The usual flow.
Exactly. Seems straightforward. But what happens when each of those bits is a separate microservice?
Yeah, that's where it gets interesting.
So let's say payment goes through, points get added, but then, uh-oh, the shipping service fails, maybe the stock count was wrong, items damaged, whatever.
Right. Something goes wrong downstream.
And now you've got this mess, money's taken, points are awarded, but no product is actually going out the door. It's inconsistent.
Totally inconsistent. And you can't just, hit a magic undo button that spans all those different services. It's not like rolling back a single database transaction.
No way.
And that's really the core challenge, isn't it? Coordinating changes across all these independent services.
Yeah.
Especially for business operations, that might take a while.
Take a while. You mean not just milliseconds?
Definitely not. We could be talking minutes, hours,
Mm-hmm.
sometimes even days for certain processes. People sometimes call these LLTs.
LLTs, long-lived transactions.
Exactly, long-lived transaction.
Okay. And our old friend, the reliable ACID guarantees. Atomicity, consistency, isolation, durability. They just don't cut it here.
They really, really don't. Not across services like that. ACID is fantastic within one database, but trying to stretch it across multiple services for a long-running process.
Sounds like a recipe for disaster.
It pretty much is. You'd have to lock resources in potentially, completely unrelated services for ages.
Which would just kill performance. Massive bottlenecks.
Huge bottlenecks. Plus, you'd be tightly coupling services that are supposed to be independent. Makes the whole system super fragile.
Fragile how?
Well, if just one service in that long ACID chain gets slow or goes down, the whole distributed transaction grinds to a halt or fails entirely.
Okay, so trying to force traditional transactions actually makes the system less available overall.
Precisely. You lose one of the big advantages of microservices, the independent resilience and availability.
Okay, so distributed world, long-running processes, traditional transactions are out. What's the alternative? There must be some way to keep things consistent, right?
There is, and that's where the Saga pattern comes into play.
The Saga pattern.
It's designed specifically for managing these long-lived transactions in distributed systems without relying on that global ACID lockstep.
So a saga, it takes that big, complicated business process, like our order example, and breaks it down into smaller, separate steps.
Exactly that. Each step in the saga is usually its own local ACID transaction, happening within just one service. That part's fine.
Okay, local ACID is good.
But here's the critical difference. The saga as a whole, the entire sequence, doesn't guarantee atomicity like a single database transaction. If step 3 fails after steps 1 and 2 succeeded.
It doesn't automatically roll back steps 1 and 2.
Nope. Not automatically in the technical sense of a database rollback.
Right. This feels like a really key distinction, especially, if you're discussing system design, maybe in an interview context. You're saying sagas provide a business-level consistency.
That's the term. Business-level consistency. Not strict technical ACID atomicity across everything.
Yeah.
That's a crucial point, and yeah, something interviewers definitely listen for.
So what's a red flag, then, in an interview related to this?
A common one is when a candidate talks about sagas as if they do provide the same guarantees as a monolithic ACID transaction, they don't.
Okay.
Sagas give you a way to manage the state of that long process, track where it is, and critically, a defined way to handle failures to maintain business invariance. Even if the technical state isn't perfectly synced everywhere all the time.
Business invariance. Keeping the business logic consistent. Okay. So back to our failed order. Stock checked, payment taken, points awarded.
Right.
Then shipping fails. What now?
Right. You can't just tell the payment service database to magically undo its transaction from the shipping service.
So how do you fix it?
This is where compensating transactions become essential. It's the core of Saga failure handling, backward recovery.
Compensating transactions. Okay. So when a step fails.
You trigger a sequence of new transactions, and these new transactions are designed specifically to undo the business effect of the steps that already completed successfully.
Undo the business effect. Okay, interesting phrasing. Not literally rewinding the database state.
Correct. Think about it. A database rollback happens before the local transaction commits. It's like it never happened.
Right.
A compensating transaction happens after the original step's local transaction already committed. It's a new transaction moving forward in time that performs a semantic reversal, We sometimes call it a semantic rollback.
Semantic rollback. I like that. So for take payment, the compensating transaction is issuing a refund.
Exactly. For award points, it's deducting those points. For reserve stock, it's releasing that reservation.
Okay, makes sense. You're not erasing history. You're adding a new action that cancels out the business result of the old one.
Precisely. And often, keeping that audit trail, seeing the original action and the compensation is really important for debugging, for compliance, all sorts of reasons.
What about things that are hard to truly undo? Like, say, one step send an email notification. You can't really unsend an email.
Great question. That comes up a lot, actually. It's a classic interview follow-up.
Okay.
You're right. You can't unsend the email. So for actions like that, the compensating transaction might be to send another communication.
Ah, like a follow-up email.
Yeah, maybe a second email saying, actually, that order was canceled. Apologies, you're being refunded. The goal is to address the business impact and get the system back to a consistent state from the business perspective, even if the history shows both the original email and the correction.
Got it. So designing these compensating transactions, it's just as important as designing the main steps.
Absolutely critical. You need one for every forward step whose business effect might need to be reversed if something later fails.
And there was another term you mentioned, idempotency. That's important here too.
Vital. Both the main Saga steps and their compensating transactions must be idempotent.
Meaning you can call them multiple times, but it only has the effect of being called once.
Exactly. In distributed systems, especially with messaging or network retries, it's very possible for an operation to get delivered or triggered more than once. If running your refund action twice actually refunds the customer twice, well, that's bad.
Yeah, very bad. Okay, so ignoring idempotency is a major anti-pattern, a big red flag when designing sagas.
Definitely. You need to build idempotency in from the start, usually using some kind of unique request ID or checking current state before acting.
Good tip. Now, thinking about design, can you structure the saga itself to make rollbacks easier or maybe less likely to need lots of compensation steps?
Yes, absolutely. Strategic step reordering is a really powerful technique here.
Reordering the steps, how does that help?
You look at your steps and figure out which ones are, say, more likely to fail, or maybe which ones have compensating actions that are really complex, expensive, or maybe even impossible to truly reverse.
Okay, the risky or difficult to undo steps.
Right, and you try to put those steps earlier in the saga sequence.
Earlier, that feels backward. Why put the risky stuff first?
Think about the scope of the rollback, if that risky step does fail. If it fails early on, fewer steps have already completed before it.
So fewer compensating transactions are needed.
Exactly. Fewer things to undo. Let's take our order again. Maybe shipping is inherently risky, physical warehouse issues, etc. If shipping is the last step and it fails, you have to undo stock reservation, payment, and loyalty points.
Right, 3 compensations.
But if you could somehow put shipping before awarding loyalty points, for example, and shipping fails then
you only need to compensate for stock and payment. You never even got to the points step.
bingo. You minimize the potential blast radius of the failure.
Okay, that makes a lot of sense. So the principle is, put steps that are high risk or hard impossible to compensate as early as possible, and steps that are low risk, easy to compensate, or maybe even irreversible but okay to leave done, push those later.
You got it. Analyze the failure probability, compensation complexity, irreversibility, and business importance of each step, then sequence them intelligently. It can dramatically simplify your failure handling.
Smart. Okay, so we have our steps, we have our compensations, we've ordered them thoughtfully. How do we actually coordinate this dance across the different services? You mentioned 2 main styles.
That's right. Orchestration and choreography. Those are the 2 dominant patterns for implementing sagas.
Let's tackle orchestration first. What does that look like?
Okay, with an orchestrated saga, you have a central coordinator. Think of it like a conductor for an orchestra. This service, the orchestrator, knows the entire sequence of steps for the business process.
It holds the master plan.
Exactly. It sends commands to the participating services telling them, okay, service A, do step 1. When service A confirms, it tells service B, do step 2, and so on. It keeps track of the overall saga state.
And if a step fails?
If a service reports back failure, the orchestrator is the one responsible for initiating the rollback. It knows which steps completed, and it sends out the commands for the necessary compensating transactions, usually in the reversed order.
So in our order example, maybe there's an order orchestrator service. It tells warehouse, reserve stock. Warehouse says, okay. Orchestrator tells payment, take payment. Payment says, okay. Tells loyalty, add points. Loyalty, okay. Tells warehouse, initiate shipment. Warehouse says, failed.
Right. And then the order orchestrator swings into action. It tells loyalty, deduct points, tells payment, issue refund, tells warehouse, release dock reservation.
Okay, a very clear command and control flow. The big advantage seems to be visibility. You know exactly where the process logic lives.
That's the primary benefit. Centralized logic makes the flow easier to understand, easier to monitor because the orchestrator knows the state, easier to debug when things go wrong, and arguably easier to onboard new developers onto the process.
Sounds pretty good. What are the downsides then? Is there a catch?
Well, the orchestrator itself could become a potential single point of failure. You need to build it to be highly available,
Makes sense.
and it introduces coupling. The orchestrator needs to know about and directly call every service involved in that saga.
Okay, so it's not completely decoupled.
No. And there's a risk the orchestrator becomes too smart, pulling domain logic out of the individual services, leaving them kind of anemic or just simple CRUD services.
Right, you want the orchestrator just managing the flow, not doing the actual work of each step.
Exactly. The services should still own their specific business logic. The orchestrator just tells them what to do next in the sequence. You can mitigate the single point of failure by having maybe multiple more focused orchestrators, like one for orders, one for returns, etc.
Okay. Sometimes people use tools for this, like business process engines.
Yeah, you see tools like Kumunda or Zeeby used for orchestration sometimes. They let you model a workflow visually, though honestly, many teams end up coding the orchestration logic directly for better testing and version control integration.
Gotcha. Okay, so orchestration. Central control, good visibility, potential bottleneck, potential coupling. What's the other side of the coin? Choreography.
Choreography, yes.
Yeah.
It's the opposite approach. No central orchestrator.
No conductor. How does anything happen?
It's all event-driven. Think of dancers who know their steps and react to cues from each other rather than watching a conductor.
Okay.
Each service performs its part of the saga when it receives an event it cares about. When it finishes its step, its local transaction, it publishes its own event. Other services are listening for those events, and that triggers their next actions.
So the process starts with an event, maybe order placed.
Yep.
The warehouse service hears that, reserves the stock, and then emits stock reserved.
Could be.
Then the payment service is listening for stock reserved, hears it, takes the payment, and it emits payment taken.
Exactly. And maybe the loyalty service also listens for payment taken and awards points. Perhaps at the same time, the warehouse service is listening for it to initiate shipping. It's a chain reaction of events.
Interesting. So services are really decoupled here. They just care about the events they consume and produce.
That's the main selling point. High decoupling, high service autonomy. Services don't need to know about the orchestrator or even which other specific services are involved downstream.
That feels very aligned with microservice ideals. Independent teams can work on their services more easily.
Definitely. It's often favored when the saga spans services owned by different teams. They can evolve their service and its event handling mostly independently.
But what's the catch here? If there's no central place managing the flow, how do you even know what the overall process is? Or track a specific order if something seems stuck?
That is the big challenge.
Yeah.
The overall business process is sort of emergent. It's implicitly defined by this web of event publishing and subscribing. Getting a global view is much harder.
So monitoring and debugging must be tougher.
Significantly tougher than with orchestration, yes. Understanding the current state of one specific saga instance or tracing why it failed requires more work.
How do you debug it then? If a customer calls asking, "Where's my order?" how do you piece together what happened across 5 different event-driven services?
This is where correlation IDs become absolutely non-negotiable.
Correlation IDs. Okay.
When the saga starts, say with that initial order-placed event, a unique identifier is generated just for that specific order's saga instance. Let's call it the correlation ID.
Right.
That ID must be included in every single event emitted, every command sent, every log message generated by any service participating in that specific saga instance.
Like a tracking number that follows the entire process through all the disconnected steps.
Exactly. Each service picks up the correlation ID from the incoming event or message, does its work, includes that same ID in its logs, and passes it along in any event it emits.
So even though the logic is distributed, you can use that correlation ID to query your central logging or tracing system and pull together all the related events and logs from all services for that one saga instance, like breadcrumbs.
Precisely like breadcrumbs. You need good observability tools that can aggregate and query based on that ID, without robust correlation ID propagation and tooling, debugging choreographed sagas becomes incredibly painful. It's a critical anti-pattern to mess that up.
Wow, okay, so it really sounds like a fundamental trade-off. Orchestration gives you that explicit control and visibility for couples things. Choreography gives you decoupling and autonomy, but you sacrifice that central visibility and really need solid observability and tracing with correlation IDs.
That nails it. That's the core decision.
Yeah.
Often the guideline is, if one team owns all the services in the saga, maybe orchestration is simpler day to day. If it spans multiple teams, the decoupling benefits of choreography might outweigh the complexity, if you invest in the necessary observability.
Or maybe even mix them, a hybrid approach.
You could. Maybe orchestrate the main flow, but have certain steps trigger choreographed subflows. It depends on the complexity.
This has been super clarifying. So let's zoom out again, thinking about interview prep. What are the absolute must-know takeaways here?
Okay, first, understand why sagas exist. They solve the long-lived transaction problem across services where global ACID is impractical due to locking and availability issues.
Got it. Because
Yeah.
ACID kills availability in distributed systems.
Right. Second, the core failure handling mechanism is compensating transactions. They perform semantic rollbacks after local commits to maintain business-level consistency.
Business level, not technical ACID atomicity. Crucial distinction.
Crucial. Third, be able to distinguish between business failures, handled by Saga compensation, and technical failures, like a network blip or service crash, handled by infrastructure, like retries, dead letter queues.
Good point. Sagas handle the logic fails, infrastructure handles the plumbing fails.
Kinda, yeah. Fourth, know the two main styles, orchestration and choreography. Understand their mechanics, commands versus events, and their trade-offs. Central control visibility versus decoupling observability challenge.
And be ready to talk about when you lean towards one or the other.
Exactly. Fifth, remember those key implementation details, strategic step reordering to simplify rollbacks, and the absolute necessity of idempotency for all steps and compensations.
And for choreography, the critical role of the correlation ID for tracing.
Yes, nailing these concepts and using the right terms, Saga, compensating transaction, orchestration, choreography, correlation ID, idempotency, eventual consistency, shows you really understand the challenges and solutions for building resilient distributed systems. It signals you can handle complex design discussions.
Okay, one last thought then. If sagas achieve consistency through this sort of after-the-fact cleanup using compensation rather than strict prevention like ACID, what does that really mean for the business or the user?
That's a fantastic question to ponder.
How does a user perceive a semantic rollback compared to just an initial error?
It's a totally different experience, right? Getting an order confirmed, email, maybe even a shipping notification started, and then getting an canceled and refunded email feels very different than if the place order button just failed immediately.
Yeah, it feels like something went wrong later, maybe something more serious.
It highlights that consistency in these systems isn't just a technical database level concern. It's a business process concern, a user experience concern. You have to design the communication, the expectation management, the audit trail around these compensating flows just as carefully as the technical implementation. How do external systems interacting with yours perceive that undo? It's a bigger picture.
Absolutely. It's not just code, it's the whole experience. Well, hopefully this deep dive has given you listening the clarity, the vocabulary, and the confidence boosters needed to talk about these Saga patterns effectively.
Yeah, maybe think about systems you've worked on. Did they use sagas? Could they have benefited from them? How were long-running processes handled?
And hey, if you found this useful, definitely give us a like, subscribe for more deep dives like this, and please drop a comment below. Any follow-up questions, specific scenarios you want us to explore next time, we read them all.
Your feedback really helps us shape these conversations. Thanks for diving deep with us today.